Hello everybody. Welcome to the Innovation Day by SolidWorks. Myself, I am Rajesh Celestine, working as a Senior Application Engineer for Atmata in Dubai. Having an experience of around 20 plus years in various industries as a mechanical design engineer, I started my tenure from the board to today's technology with CAD. So it was always been a challenge during my tenure in seeking the right needs and solutions for our design needs. So based on my experience, I have been also supporting customers in implementing and providing solutions with today's latest technologies in software for the design needs. So let's get started with today's session. Okay, in today's session, I'm going to show you how we are going to design this cooker handle. So most of our designs are of old, so we will have to reverse engineer this and use the proper tools to design this handle. So here I am going to use the 3D Sculptor and the 3D Creator, which are cloud-based apps, and then we are going to validate this by doing a thermal simulation using the SolidWorks desktop. So most of the users have SolidWorks desktop, which can also be connected to the cloud. And without any data loss, we are going to see how we could seamlessly collaborate using the 3DExperience platform. Okay, so the process I have used here is a reverse engineering concept for the handle, where I could start with a sketch or also take a photo. So I use the cloud-based apps, which is Xshape and Xdesign, where you can design it within a browser. And then I run my product validation, which is a thermal simulation with SolidWorks desktop connected to the cloud. So the first stage in our design is we need to shape our product. So here I have two views, which is the front view and the top view. I'm using Xshape to shape my product and align it to the sketched views. This works on a sub-D modeling technique, and which is a powerful tool to generate complex shapes. So let's see how. Okay, so here I have my Xdesign, which is a browser-based app. I start with a new component, enter my file name, select my collaborative workspace, which is a dedicated workspace where I can save all files to. So we will start by inserting the picture. So I will choose my picture here, which is the front view. Select my reference plane. And I would slightly like to rotate my image. So using the on-screen angles, I can rotate my image. So here I enter a value of 1.5 degrees. Set the transparency to 50. Use the on-screen points to adjust the size of the image, where the size of my handle is around 150 mm. So I type in 150 and say OK. So this resizes the image. So now let's insert the top view. So I select my top view, select the reference plane to be inserted on, and when I slightly view my top view, it is rotated around 90 degrees. So I use the on-screen angles to rotate it to 90 degrees. Change the transparency to 50. Now in this case, I'm going to use the manual method to resize my image. So this image has to be resized to align or to suit the front view. So let me do some more fine tuning to this and click OK. So having inserted my images, now I am an Xdesign app, which is the 3D Sculptor role. When I press X on the keyboard, I can quickly transit into Xshape. So everything starts with the primitive. So here I'm selecting the box as my primitive, and I use the midplane option to position it. I can also scale it and I have the options to increase or decrease the divisions or segments in the X, Y, and Z direction. So I would need a few additional segments in the Y direction. So having 5 as my divisions in the Y direction, I complete the primitive. So here, let me resize it to the extents. I also have the option where I can change the transparency of the solid to view a clear picture or the profile of my sketch. So the first step I do here is I change the vertices or drag the vertices to meet the extents. So I would need some additional loops where I can insert additional loops to have a greater control over my geometry. So having done this, I would like to refine or align my vertices to the sketch profile. So you can do this by selecting the on-screen vertices, edges, faces, loops, and by selecting the vertices you get an on-screen robot where you can drag and position your vertices. So the options you have with the robot is dragging, rotating, and moving, and also scaling the vertices. So let me select the bottom vertices and slightly drag them down. So let me add some additional loops since I have to do a refinement to the bottom portion of the handle. Filters are available where I can select loops, edges, rings, vertices, and so on. So here, selecting the loop filter, I can select the loop and I can move them slightly to adjust the geometry. So I would select here the required vertices, and I have a very good tool here. This is a powerful tool which is called the Sketch Align tool, where I can draw on screen to align these vertices to the sketch drawn. So having drawn my sketch, I click OK. Let me align these vertices so that I have a bit of taper, and in this case I'm selecting the Sketch Align tool and just draw a sketch, and this looks fine. So let me click OK, and it's done. So now I would like to delete some of the loops here. I have the loop delete option. So I'll select and delete some loops. Let me add a loop which is at the center. So having done this, now it's time to taper the sides. So I use the advantage of the symmetry, select the symmetry plane. So the symmetry option is a powerful tool where you could change the or reshape the vertices on one side, and the same reflects on the other side. So I'm using the line align tool by selecting the vertices, and you could see like I changed it on one side and it reflects on the other side. So it is a symmetry option here. So it looks fine. I can change my transparency and have a check on my image. So I can switch off my sketch images. Now I would like to refine the top portion of the handle. So using the same Sketch Align, which is a very powerful tool where you could sketch on screen and align vertices to the sketch you had drawn. So let me do some finer tweaking here. Select the vertices, draw your sketch. And this looks fine. Now I would like to slightly drag it to the extents of the sketch. So select your vertices. Using the on-screen robot, you can drag your vertices. So let me change the transparency here. And here I see a slight distortion of the surface. So let me switch off my image. This can be solved by just moving the loop. So I select the loop filter and slightly move it to the top. Now when I have a look at my model, you can see I have a smooth surface. Let me add additional loops. So adding a loop, because of the symmetry option, adding a loop on one side also reflects on the other. And let me save my component and show my images. So I need to have a final look at my image. I need to check if all vertices have been aligned. So here I need to do a bit of tweaking to align my vertices onto the profile. So by selecting vertices, I also can align the robot to the local XYZ as well as the on-screen XYZ orientation. So select the vertices and drag them to match or to merge onto the profile. So having done this, I see that my shape is good, and I run the zebra analysis where I could identify any distortion in faces. Okay, so what we saw here was Xshape, which is a cloud-based app on the 3D Sculptor role, is a powerful tool where you can design complex shapes and surfaces. It's very easy to implement or bring your ideas to life from a simple sketch on a browser, anytime, anywhere, and on any device. Okay, so having done my design or shaping with Xshape, now it's time to move to create my mechanical features. So in this, I'm going to use the 3D Creator role, in which we have the XDesign app, and this is also a cloud-based 3D parametric modeling app in which I can create all functional mechanical features, and then I'm going to analyze for a draft on the surfaces, as this part is to be created by a mold. Let's see how. So having done my shaping in Xshape, now I can quickly move to XDesign. Typing X on the keyboard and selecting XDesign transits me into XDesign. So let me create a parallel plane so that I could draw the profile for material removal. So let me hide my geometry, select a sketch, and pick the plane to be sketched on. Now let me draw a center line which will act as a symmetry or a mirror line. So by selecting the line and the origin, you can see the flyout with the sketch constraints to be applied. So let me pick the center line and convert it to a construction line. So let me quickly draw the profile of the extrusion to be cut with some lines and splines. Okay, let me add some constraints to it and mirror this profile to have a symmetry. So here we see familiar tools we use in sketches, and once it's done, I exit my sketch, switch on my subdivision surface, and now I can do an extrude of the profile drawn. So let me extrude this profile. So in this case, I'm going to add an option up to geometry, since I need an offset from this top profile of a distance of around 5 mm. And also I'm going to apply a draft to it. Since it's a molded part, I need a draft of around approximately 3 degrees. So here we see that there is a solid body which has been added into it. So I can edit the extrude and swap between adding material and removal of material. So I select the cut option and click OK, and it's done. So the material has been removed. So to make this faster, I've completed the model. I have added all the cutouts or material removal wherever required. And now let me quickly do a draft analysis for 2 degrees. So I select the plane, and you can see the yellow faces which represents drafts which are needed. So I can easily tweak my sub-D modeling by selecting or editing the sub-D surface and just dragging the vertices and edges on screen with the draft analysis on will give me a visual look of faces which needs to be drafted. So as I keep moving, you can see that faces which falls under 2 degrees or greater will get cleared of the yellow color. So let me select these edges and drag it, and this is a very minute difference for the draft required, and it's done. So once I'm done, let me save my file to my collaborative space. Okay, so what we saw here is we saw the draft analysis, which is a very powerful tool on the 3DExperience platform. Sketches, sketch constraints are very familiar tools which most of SolidWorks users know. Also, we saw a seamless transitioning between the roles without any loss of data to achieve the required geometry and design intent. Okay, having completed my component on X shape and X design, now it's time to run a thermal analysis to validate my component. So I'm doing this with the help of SolidWorks desktop, which is connected with the cloud with the SolidWorks connector. The material used here is bakelite, from which I've got the physical properties of the material from the net, and this is built into a custom library. I'm running a thermal analysis for a maximum steam temperature of around 120 degrees Celsius, a radiation temperature of around 20 degrees Celsius, and an emissive factor of 0.75. Let's see how we do this. So having designed my component on the cloud, now I can start SolidWorks by clicking on the SolidWorks connector. So this opens SolidWorks from the 3DExperience platform. Now I would like to drag and drop my file into SolidWorks. So I go to my collaborative space where I've saved my file, drag it and drop it into SolidWorks. So we see here the transition is quite easy without any data loss. So the material applied for this handle is a bakelite. So let me apply the material. So this has been done by creating a custom material. So custom properties have been added here. So I have created a bakelite material with all the custom properties from which I got the data from the internet. So here this is bakelite 6507. So the required parameters were entered into the custom materials. And now let me add in the SolidWorks simulation. So I click on the simulation tab and let me start with a new study. So in this case, I'm going to run a thermal simulation. So I click on the thermal simulation option, and just to save time, I've already created a thermal study. So here I have applied a temperature load of around maximum 120 degrees Celsius. So this is the maximum steam temperature of a cooker. And the faces selected is the contact faces with the metal. Then I'm applying a radiation to the remaining faces, which are all exposed. So this is going to have an ambient temperature of around 20 degrees. as well as an emissive factor of around 0.75. So having done this, let me say OK. Now let me run the study. So let me click run the study, and SolidWorks meshes the model, creates the mathematical model, and solves for thermal analysis. So once done, you can see the results here. So the faces of contact is having the maximum temperature, and as the temperature moves to the end, you can see the temperature values based on the color codes. So here I can also probe temperatures at different points or at different nodes. So I run the probe tool, and you see I can pick nodes, and you can see it gives the value of the temperature at that particular node. So any number of nodes you can pick to get an insight into the temperature at that particular location. So let me click OK to close it. And I can save this file locally. If you do not have an internet, you can save your file locally. And once you have the internet connection, it can be saved to the cloud. Okay, what we saw here was me having the SolidWorks desktop, I was able to work from the cloud or take data from the cloud and work with any of the SolidWorks add-ins. Like most of the users have SolidWorks desktop, which can always be and anytime be linked to the cloud. So this happens without any data loss, and there is a seamless transition between roles to achieve the required design intent. Okay, just to summarize on the demonstration. So here I started with a simple sketch. I have used the 3D Sculptor role, which is having the X-shape app. So the X-shape app benefits in creating your organic shapes, and I can say it is a kind of advanced surface modeling. And then what we did is we took a transition into the 3D creator, which is XDesign, and here I added my mechanical features to the part or to the organic shape. And we also saw some validation tools of like the draft analysis, the zebra analysis, and so on. So you have a lot of tools. So this workflow, I've used a few of the tools. And the 3D Sculptor and the 3D Creator is a cloud-based app which works on a browser. And then we took our geometry into the SolidWorks desktop. So this is possible with the collaborative designer for SolidWorks. So we saw a seamless transition from the cloud to the SolidWorks desktop, where I did my thermal analysis. So this makes it possible with the collaborative industry innovator and the collaborative business innovator. So having these two as the basic platform, you have a lot of roles and apps which will meet your design needs. This is my company website. You can connect with us on LinkedIn and follow us on Facebook, Twitter, and Instagram. I believe this session would have given you an insight into the 3DExperience and SolidWorks and would have been beneficial to you. Thank you so much for joining my session. Have a great day.